Hi everyone. So in this video, I shall be discussing solutions of IAI March 2020 CS2 A paper. Before we get started with the paper, just one announcement or rather one update, which a lot of you would already know about, is that the next set of examinations from IAI would be from July 2022 session. A few of you might have questions, then what happens to the September session, the month in which traditionally exams were held in recent past. So there is no clarity on that yet. It seems very unlikely that the next set of exams after July will be in September, given the short span. So there could be an examination later in the year, as many are speculating that there is a possibility going forward there would be 3 examinations held by IA in a year. But again, for all these, we need to wait for some formal communication, which would be made available on the website of IA. As for the classes being held by Finatics, admissions are open for July 22 session, September 2022 session for IFA, as well as for whichever next term is held in II after July. We just have a single batch for each paper. So ones who are interested to join us, do join us at the earliest. We would be conducting offline batches starting from City Kolkata for this session, September 2022. Beyond that, we might open up offline centers in other cities as well. Online batches would be available. So any one of you, irrespective of your location, would be having access to that. There would be a single batch, as I said. Classes would be held regularly, both on weekdays as well as weekends. And obviously, all of you would be getting the facility of video backups as well. So this was regarding the update of IA as well as the classes for the next session. Coming back to the paper, so first to give just a high level view of how I found the CS2 A paper, I would say it was a decent paper. I mean, in the larger scheme of things, keeping in mind that 50 is the pass marks, I mean, attempting 50 for any moderately well prepared student is also, very easy. And the well prepared students would have been able to attempt a significantly higher amount of questions. So it was broadly in line. There were few theoretical questions, so we do have a tendency to ignore those. So some of the students might have struggled, but apart from that, if you would have asked as for the difficulty compared to the past years, whether it's CS2 from II or CT4 or CT6, this I would say was on the slightly easier end. So let's take a look at the first question. For a discrete time stochastic process, define the terms. Stationary, weakly stationary. So when they just mention stationary, it basically means strictly stationary. Increments, Markov property, and martingale. So these are direct bookwork questions. Again, martingale is something which a lot of you might not have heard maybe in CS2, but it is something which is there in CM2 as well. They have asked this though here. So just to give you a brief, martingale is nothing where the the future expected value of the process is the current value. Then a process is said to be a martingale. Alternatively, if the expected change in process is zero, then that is also said to be a martingale. It's the same thing. When we say that the expected future value is the current value, it is an equivalent way of saying that the expected change in value of process is zero. So the first part was direct bookwork, 5 marks. Part 2, we have a process Sn given by S0 plus x1, x2, xn, and S0 takes the value m. And we need to explain whether the following properties are being held or not. So let's just take a look at how we should go about with the solution. Sn is equal to S0 plus x1 plus x2 so on xn. If I just leave the last term xn and I take it till xn minus 1, then that becomes nothing but Sn minus 1. So this is another way to write. Why I'm writing this is so that later on this would be helpful. Now S0 is given to be m and xt takes the value plus 1 or minus 1 with probability p and 1 minus p respectively. So first let us compute expectation xt. It will come out to be 2p minus 1, and then if I calculate variance of xt, this comes out to be 4p into 1 minus p. Now we are interested in the properties of Sn, remember that. So expectation Sn, we take expectation of S0 plus x1, x2 so on, and this becomes m plus n into 2p minus 1. Clearly, as n varies, this particular expectation will also vary unless p is equal to half. If P is equal to half, then this term becomes 0, but then that is a specific case. Generally for any value of P, if I can consider any set of values of P, then expectation Sn is a function of n. So clearly mean is not constant, therefore the process is not weakly stationary. And if a process is not weakly stationary, then definitely it cannot be strictly stationary as well. Next, I have Sn minus Sn minus 1 is equal to Xn. This is directly coming from the first line which we had written. Now clearly Sn minus 1 is nothing but Xn, and this is this is the increment of Sn, and we clearly see that this is independent of the past. Your Xn takes a fixed value. Whatever is the value of Sn minus 1, anything, my Xn always takes the value 1 or minus 1 with probabilities P and 1 minus P respectively. So what we can say is that the increments of the process are independent as well as they are stationary, because obviously the distribution of Xn remains unchanged. And since the process has independent increments, therefore it will be possessing the Markov property as well. For the process to be martingale, expected change in value of process should be 0. So let's say if I just take expectation of Sn minus 1, which comes out to be expectation Xn. So clearly we saw that expectation Xn was not 0 for all values of P, only in a specific case it was. So generally the process is not a martingale, because we would want expectation Xt to be 0, which is not the case. So this was question 1. Again, a lot of you might have had issues, specifically ones which is the ideal way, ones who appear for CS2 before CM2, then you might not be aware of the term martingale. So, I mean, you could lose, let's say, 2 marks out of a total 11, but the rest 9, I would say, was pretty scoring. Question 2, I would say a very funny question. You all might think it's a Markov chain, we need to create the model and so on. And now we'll just go about and see that, that is not the case. Given the choice of options they have given, they have made life pretty easy for the students. So I'm not even going into reading the question, because I'll tell you why it's not required. Part 1 defines stationary probability distribution and its role in different Markov chains. This is plain direct bookwork. Part 2 is which of the following in agents movement transition probability matrix P in terms of the grade they are in and when they leave the company of a discrete time Markov chain. Now just remember one thing, that in a transition matrix, all rows must add up to 1, right? Let's take a look. First row 1, second row 0.06 plus 0.97. It's more than 1. A option cannot be correct. Let's take a look at B option, 0.03 plus 0.96 plus 0.04, more than 1. I'm not even looking at the states right now, whether we need 4 states, 5 states, forget right now. All we want is that it is a necessary condition that all rows must add up to 1. B is also correct. If I took a look at C in second row, 0.06 plus 0.03 plus 0.97. Again, this is more than 1. So automatically I'm left with D only, and D is the correct choice. So this was I would say a hack, or students who have good observation skills, they could have directly eliminated A, B, and C, and without even trying to understand the question, they would have solved D. And once you have this, other parts can be done simultaneously, because the key thing in a Markov chain is to get the transition matrix. So you'll see they have written almost half a page. Even if you haven't been able to interpret it, although it wasn't anything difficult, you could still have got the answer and would have continued for the entire question itself. So this is where your presence of mind needs to be there. A lot of times we all tend to get, let's say, panicky when a question from Markov chain comes and we see we are not being able to crack it. Still, here you could have solved it very easily. So this is option D itself, and I mean, normally you could have solved given the information in the question, and the hack was, for all other options, rows don't add up to 1. Question part 3. Suppose the company has 300 agents at the beginning of week 1, distributed as 150. As 150 in grade A, 75 in grade B, so on. Calculate the expected number of agents in each grade at the beginning of week 3. So basically we're at the beginning of week 1. There will be 2 more transitions from week 1 to week 2 and then week 2 to week 3, right? So what we want is basically p square into the initial distribution in the different states. So what we are looking for is 150 into 75, 150, 75, 45, 30 into p square. Now I've taken the help of R programming to calculate this. Obviously, you're not allowed to do that in the examination. You would have to do it on pen and paper only. So we have p, you might need to get first p square and then you need to multiply it. And this has been rounded off to the nearest integer. You could express your answer, let's say exactly, which is not preferable given it could be very long, or up till 2 decimal places as well. Final part is basically calculate the expected number of agents in each grade in steady state. So what I basically am looking for is the stationary distribution. I know initially I have 300 agents, right? And so in this, let's say in the long term, basically, I mean, the station distribution will give us the proportion of people in the respective distributions. If I multiply it by 300, I would be getting the expected number of agents in the steady state, or that's it in the long term state. So pi p is equal to pi. I get the value of pi, which is nothing but the stationary distribution. Again, the workings is something which I've not shown here. I took the assistance of R programming to calculate this. Otherwise, it's a normal way. You'll have multiple equations and need to solve them simultaneously. Expected number of agents in steady state is you multiply 300 with each of these terms. And here, if you would try to round it up to the nearest integer, since you know all of these are less than 0.5, so there will be a difference of 1. I mean, when I add all of them up together, it will come out to be 299, and that is why I've expressed till 1 decimal place, so that that property of adding all of them up should give 300 does not get loosed out. So these are certain things you need to keep in mind while rounding off. Here I could round off and the total was coming 300. Here, when I was trying to round up to the nearest integer, that was not the case. Question 3. Which class of patient does the baseline hazard represent? So baseline hazard represents wherever all the covariates takes the value 0. So Z1 will take the value 0 when age is 30. Z2 will take value 0 for female, and I want Z3 and Z4 to be 0, which basically implies that procedure C needs to be adopted. So my baseline case here will be females aged 30 years who had transplant using surgical procedure C. Next, we have been giving the values of various beta, which compare the survival period of a male age 40 with surgical procedure A with that of a female age 45 with surgical procedure B. So what we could do is we could compare the hazard rates and then alternatively say, that this first individual has, let's say, X% higher mortality compared to person 2, or Y% less than compared to B, depending on the ratio which we get. So I have tried to show all the steps. This is for the first life, lambda 1t, ages 40. And these are the various covariates which are coming, either taking the value 0 or 1 multiplied with their beta coefficients. So we are left with e to the power 0.026 into lambda naught t. For the second life, again, it comes out to be e to the power 0.06. So we can say that mortality of life 2 is higher than that of life 1. And you can also give a percentage. Let's say, you divide this divided by this, and you can say that the mortality of life 2 is higher than X% with respect to life 1. Next part, again in the question they had mentioned that we bring in another second model, which has 2 interaction terms given by this, and further beta 5 beta 6 is also given. So we again need to find, let's say, the hazard which we did in part 2, incorporating Z5 and Z6 as well. So that modification has been done. 0.026 becomes 0.0281 and 0.06 becomes 0.0600. Double three, there's an extra 0 over here, I guess. Yeah, there's an extra 0 over here. So again, you could just check the calculations. I just suddenly now feel that there is something wrong over here, 0.00033, but yeah, this can be checked. Part 4, we need to check which model is more suitable. So S2 minus S1 follows chi-square 1 minus 2. Remember that S2 minus S1 can also be written as minus 2 log minus twice difference of the log likelihoods. So my test statistic here will be 2 into 64.34 minus 64.21, which comes out to be 0.26. The critical value of chi-square 2. Now remember that the second model has two additional parameters. So my chi-square will be basically 1 minus 2 means number of parameters in model 1 minus number of parameters in model 2. My model 1, I would say, has more number of parameters. That is the way it has been adjusted over here. So this is 5.991. So therefore, we have insufficient evidence to reject H naught. So we can conclude that model 2 is not significantly statistically better than model 1. Question 4, this is entirely theoretical, coming right from, I would say, graduation over here, a part of it, and some parts could be, let's say, on a similar line. So this is straight away bookwork, not getting into it. Question 5, choose the odd one out. Random variability, uncertainty in parameter estimate, model misspecification, accurate data. It has to be accurate data. Next is choose the odd one out from the options below. Policy number, gender, smoker, non-smoker, age. So remember that we can use age, smoker, non-smoker status or gender as covariates while trying to model the mortality or morbidity, anything. Policy number does not give any characteristic. It is something which we assign it, arbitrary. Our policy number generally will not give us any information with respect to the mortality or morbidity details of an individual. So policy number is the odd one out over here. Choose the odd one out. Force of mortality, central rate of mortality, frequency of event, probabilities of survival or death. So everything here is with respect to mortality. So option C is the odd one out over here. So it's frequency of event. Then choose the odd one out from the options below. To analyze crude rates, produce smooth set of rates, to improve reliability of estimates, to remove random sampling errors. So, produce smooth set of rates, improve reliability, remove sampling errors. These are all, what basically graduation attempts to do, not analyze crude rates. So the odd one out, I would say, is option A. And this is the solution key over here. DACA. This is the solution key. Next, moving forward to question 6, which is of Copulas. And again, this is a similar question which is already there in the material as well. So there are bonds of 10 years. Individual default probability for each of the bonds during the first year is 20%. So first part is using independence copula, then Gumbel, then Clayton, and the last part is, which copula is more appropriate. As for the reasoning of this, I'm not going to explain in this particular video. You can take a look at the institute material, and there is a similar question. Although it does not have Clayton, it has Gumbel copula. Almost similar. Instead of 20%, it will have 10%. Number of years, number of bonds will also be 3. And then they have given the reasoning, as to how to go about attempting these sort of answers. So basically what we look at is whether we want upper tail dependence or lower tail dependence or no dependence, and then accordingly we try to make business sense out of it. I mean, this is statistical part, Copula, but here what we're trying to look at is the credit rating of a bond. So we need to see how how exactly this happens. As we move towards maturity, would we expect some sort of dependence, or if we are just initially new to the let's say inception of bond, then do we expect some form of relationship or dependency, and on these basis you need to comment on your answers. So I would say there is not always right or wrong to these things. It depends on the type of reasoning you give, and that is going to fetch you marks. As for the numerical part 6, it's independence, directly point 2 into point 2 into point 2. Next one is Gumbel. We can directly, in material you will see, we'll have it for basically bivariate case. For multivariate, you can easily extend it. And part 3 is nothing but again Clayton. So you see that the maximum answer is in the form of Clayton and the lowest answer is in the form of Gumbel. Question 7, it's again a very scoring question. It's a log normal distribution. You can directly use the results of tables, page 18, to calculate these. First one, remember, is nothing but integral of fx. So this is nothing but probability that x lies between 15,000 to 50,000. Normal standardized approach can do. No need to refer to actual tables for that, as in the formula given in page 18. For part 2 and part 3, yes, you should be using that. So let's quickly take a look at the solution. Question 7, this is part 1. and I've rounded off to 2 decimal places just so that it eases my calculation. In examination, again, depending how much time I might have, I would generally use till 4 decimal places and interpolate it. So this is just, you need to be conscious of your time. So I'm getting the answer to be 0.48499, part 1. Part 2, integral x fx dx. So in the tables, you'll see, x power of x is 1 over here. So k is 1. Calculated u1, l1, so on. Remember that phi of minus infinite, this term is nothing but 0. These are basic properties of CDF of standard normal distribution, which you all should be aware of. And it's coming out to be 3030.31. And finally, we have the third part. And here the answer is coming out to be very large, almost 1.99 into 10 to the power 9. That is probably, I guess 199 crore, something of that magnitude. Again, in case you find any sort of computational errors or any other errors in the solution which you feel, the way I have solved it is not the appropriate way, do let us know through the comments section, so that for the interest of all the viewers of this video, we could take a look at it, and in case we identify any errors, we could rectify it. Question 8, an extreme event is. So extreme events are basically low frequency, high severity. That becomes option C. As the sample size increases, the maximum value of a distribution when appropriately strictly standardized coverage is to generalize extreme value distribution. In your organization, you have observed that catastrophic risk has been modeled using normal distribution. State with reasons the improvements that you would suggest to this model. So basically, to model a catastrophic risk, a normal distribution will not be ideal because normal distribution is symmetric, whereas the catastrophic risk might not be symmetric in nature. That is first thing. We could comment about tails as well. Normal distribution is generally thin-tailed compared to other distributions, let's say like log normal. So we might want to model using a distribution which might have heavy tails or thick tail. Also on these lines, you need to attempt part 3. Next, question 9, which of the following cannot be an ARIMA 1,1,1 model? So remember one thing, just one way to recognize whether this is just a basic property, like you need to first bring yt in all the terms, then you need to see whether 1 minus b a factor or not. So for 1 minus b to be a factor of this equation, the coefficients of yt must add up to give us 0 when all expressed in a single side. So like here yt minus 0.7 yt minus 1 minus 0.3 yt minus 2. So coefficients are 1 minus 0.7 minus 0.3, which give us 0. So definitely 1 minus b is a factor. Okay. So I will tell you how to go about. Normally you would have to do it step by step, but here given it's an MCQ, I will tell you how directly you can do this. Part B also you will see 1 minus 0.6 minus 0.4. Part C, 1 minus 0.35 minus 0.3. So clearly here the coefficients do not add up to give us 0. So therefore we cannot difference with respect to 1 minus B. So option C cannot be expressed in 1, 1, 1 model. A, B, D can be or cannot be. We haven't even checked it, but C to definitely cannot be. So obviously my C is the option to be selected here. This cannot be expressed in ARIMA 1, 1, model. Next is we need to comment on this model. We need to express an ARIMA PDQ form. So here we need to go through the normal way to go about it. So I've started with over here xt. I've brought all the terms over here, and then I've performed long division starting with 1 minus b, and I get 0.5 b square minus 1.5 b plus 1, which this particular term, note that, can be written in this form: 1 minus b into 2 minus b into half. So clearly I see 1 minus b has a power of 2, 2 minus b. So basically p is 1. On the RHS I have q as 1 and d is 2. Excuse me. So it's ARIMA 1, 2, 1 model. Part 3, which of the following type of series do the following expression belong to? Xt is equal to 0.2t. So 0.2t means there's basically a particular trend over here. As t keeps on increasing, this will tend to increase the value of xt as well. So this will basically be option 3, part A, series with a trend. Part 4 and 5 are from machine learning. Part 4, we need to apply Euclidean distance, which is basically root over x1 minus x2 square plus y1 minus y2 square. And part 5 is basically the Manhattan distance, which basically takes the modulus value, that is mod of x1 minus x2 plus mod of y1 minus y2. And my coefficient over here is 30, 41. So Here's the thing, Euclidean distance, coordinate is 30, 41. So for C1, we'll get this as 25, C2 17, C3 18.03, C4 30.59, closest is C2. Therefore, my answer is C2, which wasn't there in option B. Note that there is C5 as well, but in the option C5 was not there. So therefore, I have not even calculated it. That is how you save time. Manhattan distance mod x2 minus x1 plus mod y2 minus y1. So again, here I guess C2 comes out to be the lowest one, 23. So that is nothing but option A. Just remember one thing, sometimes when we go at a flow now, we have a tendency in our mind. Oh, option A, C1, option B, C2, option C, C3, option D, C4. That is not the case over here. If you will see that option A is C2 in part 5. So this is just one thing sometimes we tend to go into and we make such sort of silly errors. So you need to keep in mind. For that, I will say read the question again right from the starting. Some things we try to make it obvious, and that is why that is when these sort of silly errors creep in. Finally, we have question 10 where we have a AR3 process. We need to find the formula for autocorrelation coefficient with lag 1 and 2 in terms of alpha 1, alpha 2, and alpha 3. In part 2, we know the values of all of these is 0.3 and we get the numerical values. Part 3, we find the PACF at lag 1 and 2, and then part 4, we make a comment on these. So for an AR3 process, we would expect that as K increases, my ACF and PACF will decrease. PACF in fact should cut off right after lag 3, but we are doing it for your lag 1 and 2. So therefore, what we should ideally observe is that the values of ACF and PACF should decrease. That is, the values at lag 2 should be less than at lag 1. So let's quickly let you all go through the solution. It's a standard procedure, how to go about it. So on solving, what we are getting here is rho 1 is basically alpha 1 plus alpha 2 whole divided by 1 minus alpha 2 minus alpha 1 alpha 3 minus alpha 3 whole square. And rho 2 is basically alpha 2 plus alpha 1 plus alpha 2 into alpha 1 plus alpha 3 whole divided by 1 minus alpha 2 minus alpha 1 alpha 3 minus alpha 3 square. Next part, we substitute the values of 0.3 over here. We get rho 1 as 15 by 13, rho 2 as 129 by 130. Clearly, rho 2 we see that is less than rho 1. As for the PACF, remember that at lag 1, PACF1 is nothing but my autocorrelation factor only at lag 1. And phi 2, this formula is there. Again, it's mentioned in actuarial tables. You can directly use those. Comes out to be 1.05. So clearly, phi 2 is also less than phi 1. And the commenting part is that both phi k and rho k will decrease as k keeps on increasing. More technically, phi k will get cut off after lag 3. So 5, 4, 5, 6, all of these would be basically coming out to be 0. So as you would see, it was an overall decent paper. I do expect well-prepared students to have been able to attempt at least 75 to 80 marks with accuracy. And again, as for the time factor, this paper solving entire 100 marks. If you know how to solve it, you could have done it in 3.5 hours. Typing it out or time shouldn't have been an issue in this. So hope you all did find this video useful. Don't forget to subscribe to our channel so that you do get all updates regarding all sort of new content we keep on releasing. That's it from my end. Thank you, everyone.